All right, the last chapter is going to deal with something called systems of equations. When we talk about systems, what does that mean? A system is when you have two or more equations variables. So, for example, if we have something like this, we have two equations with two variables. This is known as two by two. It's a two by two equation. And when we talk about the last part is matrices, this means we have two rows and two columns. So that's what we're going to look at this morning. So when you have two equations, what are the possible outcomes? Possible outcomes if you have two equations. We've talked about these earlier, actually. There are four possible outcomes. If the lines look like this, what do we call them? They're called parallel. And we just use that symbol to describe them. How many solutions do we have? What's a solution when we have systems? A solution is where the lines cross. A solution where the lines intersect. That's what a solution is. So if they're parallel, how many solutions do they have? No solutions. So this is line 1, and this is line 2. Or equation 1, equation 2. What if line 1 and line 2 look like this? What do we call that? It's not a tricky question. It's just if they're the same line, yeah. They're the same line. How many solutions do we have here? Infinite number of solutions. Infinite solutions. Because every point is a solution forever and ever and ever. Yeah, these are lines, so they go on forever. They're arrows at both ends. So how can we tell these two apart? They look the same. How can we tell them apart? What do they have different?
Why?
Right. They have the same slopes. But the only way you can tell them apart is parallel lines have different y-intercepts. The same lines have the same y-intercepts. Okay, those are the first two. Depending on if the slopes are the same, there can only be these possibilities. Now, if the slopes are different, these two things can happen. Where that means 90 degrees. It's a right angle. Whenever anybody says right angle, that means 90 degrees, like the corner of a room. That's 90 degrees. So if the slopes are the same, it's got to be one of these two. If the slopes are different, it's got to be one of these two. The difference is if it has a 90-degree angle, that means the slopes have different signs and they're reciprocals of each other. They're flips of each other. What is this? What are these lines called? Perpendicular. Very good. Perpendicular. And to this, in other words, we can use that little symbol there to just, whenever you see that upside down T, that means the lines are perpendicular to each other. How many solutions do they have? One solution. And the last one, the slopes are different. They only have one solution also, where they cross. And we know nothing about the slopes. They're just different slopes. Did we talk about this previously? Yes. Review your notes in chapter 1 and chapter 2. We talked about these already. Now, these are examples of systems because we have two or more equations that have two more variables. 4 possible situations can occur. Here's what we call them. Systems, they're either consistent or inconsistent. If the system is consistent, that means they have at least one solution. Okay, our example here, either they have one solution or they have infinite solutions. These are examples of consistent systems. This is the only one that's inconsistent. Inconsistent means there's no solutions. So if they have at least one or more, then they're consistent. If they don't have any, they're inconsistent. That's what has to do with the answers. Now, dependent versus independent. Two systems are dependent if, actually, in essence, they're the same line. The only thing different is they look different. For example, are these the same lines? Yeah. Because all I have to do here, all I have to do is multiply the first one by 3, distribute. I get 3x plus 3y equals 6, and it's exactly the same as the second one. So if you can do that, then it's called dependent. It's independent if you can't get them to look the same. Okay, so they're dependent if they're the same equations. They have the same solutions. They have infinite number of solutions. They're independent if they're anything else. All right. So that's the technological part of it. Now let's look at them. Solving systems of equations. I'm using the general term equations instead of specific type, like systems of linear equations, of quadratic equations, of cubic equations. So this is all the equations. In class today, we're only going to look at linear equations. What do linear equations look like?
They're degree 1,
Okay, they're degree 1. So what does it look like?
x plus a constant. Number.
So we have ax plus by equals c. Or we're used to look at them like this, like that. What form is this called?
General.
No. Standard. General is also a good word, but it's standard. What form is this?
Slope 1.
That's M stands for.
Slope
What does B stand for?
y.
So it's the slope intercept form. We're only going to look at equations that look like that. Those are linear equations. Now, solving systems of equations, we have 4 methods. The first method is graphing. The second method is called substitution. The third method is called elimination. And the fourth method is called Cramer's rule. That's how we're going to go through. We're going to look at all those. The first one. We don't use the first one too often unless we're using some sort of technology, because depending on how well you draw your graphs and how well it's labeled and everything, it can either help you or hinder your answer. So for graphing, what are the steps to graph an equation? Because let's look at these examples here. We're going to use line 1 is x minus y equals 5. Line 2 is equal to 2x plus y equals 1. In order to graph these lines, we're going to take both of these lines and graph them on the same picture, and wherever they cross, that's our answer. So how do we graph them? What do we have to do first? This is from chapter 1.
Let Y alone.
Solve for y. Put it in this form. Plot B, the y-intercept, and from B, follow the slope M to the next point. So let's do that. Line 1, what is it going to look like? I'm not gonna waste my time doing all the steps. I'm just gonna put the final answer here of what the equation is supposed to look like. So if you take line 1, what do you get? Y equals x minus 5. If you have to, move it around yourself. You should know how to do this by now. What's line 2 going to give us? So what do we notice about these two lines? Are they going to intersect? Well, let's look at this. Which one of these are going to have intersection? This one has intersection, and these two. What do these two have in common? The slopes are not the same. If the slopes are different, you'll have an answer. Again, I don't want you, when I ask a question, think about it first before you spit out an answer. Because if you don't think about it, 99% of the time, it's always wrong. Always wrong. Think about it. Write stuff down. Look at your notes. If the slopes are different, you're guaranteed a solution. If the slopes are the same, either all or nothing. The slopes are different. This is -2, this is +1. So we're guaranteed one solution. Go ahead and draw those graphs. Finished? So how do I draw the first graph? Plot the y-intercept, -5. Then do what from there? Just up 1? The slope is 1/1. Go up 1/1. If your graph is incorrect, your answer is always going to be wrong. How do we draw the next graph? Plot the y-intercept, which is 1. What's the slope? Remember, slope is a fraction. 2/1. So it says -2, go down 2/1. Connect those two dots. So what this is proposing, our solution is at 2, -3. Yeah, we can always check it. In the first one, plug in x for 2. 2 minus 5 is -3. Check. -2 times 2 is -4, plus 1 is -3. Check. So that's the right answer. Always check your answers. So that's graphing. Again, it's only as good as your graph that you make it. I gave you a sheet yesterday that had these procedures written out. This one. Step-by-step systems of equation. So solve by graphing, put it in the slope-intercept form, plot these, and you have them. By substitution, here are the steps. Choose, well, look at your sheets. Follow along so your sheets, you know what you're looking at later on. You have 2 lines, line 1 and line 2. First off, make sure they're in standard form. Make sure that they're ax plus by equals c. So choose either of the original equations. So we're going to use the same equations here. We have line 1 is x minus y equals 5, and line 2 is 2x plus y equals 1. So according to your sheet, which equation do you want to choose? Line 1 or line 2? Because once we choose the line, then we have to pick a variable. So we're going to choose, okay, so you're saying choose line 1. What variable do you want to solve for? Okay, so solve for x. We're solving for x. So we choose line 1, solving for x. So we get x equals y plus 5. This is an important equation. We'll come back to that later on to get our x value. Now, plug the equation that we just got in step one, plug that into the other line you didn't choose. Since we used line one, we got this equation. We plug this into line two. So anywhere I see an x, I plug this in place of x. I substitute it. That's where the name comes from, substitution. So since x is y plus 5 plus y equals 1, now you notice I only have one equation with one variable. What do you think I do now? What's the only logical thing you can do? Solve for y. That's what we got by itself. So we have to get rid of the parenthesis first. 2 times 5 is 10. Combine like terms. 2y plus y is 3y. Subtract 10. So those are gone. So we have 3y equals negative 9. Divide by 3. Y equals negative 3. So here are step. First step, we chose one of the two lines. We solve for a variable. Plug into the other line, not chosen. That's what we did here. Solve for the remaining variable. Now we know what y value we have. What do we do with this?
Substitute y in the for.
Plug it into solve for x. Plug this value into the equation from step 1. So x is equal to y plus 5. Negative 3 plus 5, x is equal to 2. And that's our solution. X equals 2, y equals negative 3. So the point of intersection is 2, negative 3, which is what we got last time. Pretty easy. Just a lot of moving steps. That's the substitution method. Let's look at the same equation using the elimination method now. We're going to use the same equations. X minus y equals 5. Line 2. 2x plus y equals 1. And the elimination method's on the next page. The elimination method is just that. Our first step is we want to eliminate a variable. So first step, choose a variable to eliminate. How does that mean? What does that mean? Is pick a variable that when we add the two lines together, it'll cancel.
What?
Yeah, in this case, because what we need same coefficients, opposite signs. So y, they both have a 1 and they're opposite signs. So that's the optimal one. If we can't find one, if one doesn't exist, then we have to make them. So let's go ahead and we'll do it both ways. We're going to do both ways. We're going to do y first, and then we're going to do it for x, and we'll see the same answer. So this first one, if we add these two lines together, because we're trying to get rid of the y, eliminate y. So if we add these two lines together, 1x plus 2x is 3x. The y's cancel. 5 plus 1 is 6. Solve for x. X equals 2. So we have the value for x. So the second step, we add the two lines together. Eliminating one variable. Solve for the remaining variable, which we just did. Now, the next step, since we used both lines to get to the solution, choose either of the original equations and plug that value in place of the variable. So which one do you want to plug? Which one do you want to use? Line 1 or line 2? We're going to plug in x for 2. Always choose the easiest one. So line, which one did you say? Line 1, yes. We chose line 1. Line 1 is x minus y equals 5. We know that x is 2. Solve for y. So negative y equals 3. Change the signs. So y equals negative 3. And that's your solution. X equals 2. Y equals negative 3. So 2, negative 3 is your solution. Now, as I said, would we have gotten the same answer if we chose to solve for y? So here we have x minus y equals 5, 2x plus y equals 1. This is line 1, this is line 2. Same equation. Let's see if we get the same answer. So instead of solving for y, let's get rid of x. In order to get rid of x, what do we need to have and where? We need to have a -2 in front of this one. So how do we get that? We have to multiply it, the whole equation, by -2. So we have -2 times 1 is -2x. Negative and negative is a positive. 2y. Negative, negative is a negative. 2 times 5 is 10. And just bring the other equation around. The other equation is 2x plus y equals 1. We have what we need. In front of x, the same number but different signs. So now we add. These cancel. 2y plus 1y is 3y. Negative 10 plus 1 is -9. Divide by 3. So y is equal to -3. We can plug that into the first equation. X minus y equals 5. X minus -3 equals 5. X plus 3 equals 5, which gives us x equals 2. Which means we have 2 -3. So it doesn't matter which value you solve for, you get the same answer. Those are the steps. So let's look at a couple more examples of these things. And then we'll do some word problems. We won't do graphing because graphing is only as accurate as your picture. But we'll look at the other methods. Example 3. Line 1 is 2x plus y equals 2. Line 2 is x minus y equals 7. We'll go through both methods again, the elimination and substitution methods. First off, we'll do substitution. Remember how we do substitution?
Go for one variable.
Pick one equation. So which variable you want to choose from, which equation you want to choose, and which variable you want to solve for. All right. Choose line 2. Solve for x. So we have x minus y equals 7. X is equal to y plus 7. Then what do you do with this?
Substitute the x value in the equation.
Into which equation?
L2.
Right. Since we used L2 to find this, we have to use plug into L1. L1 is 2x plus y equals 2. So in place of x, we put y plus 7. And solve for y. 2y plus 14 plus y equals 2. Combine like terms, 2y plus y is 3y plus 14 equals 2. Subtract 14. 3y is negative 12. Y is negative 4. Very good. Now you solve for x. Where do we get the x equation from? Yeah, from up here. So we know that x is equal to y plus 7. Plug that in there. Negative 4 plus 7 equals positive 3. So that is my solution. That's the point of intersection. Okay, please, 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 don't bobblehead until work it out as far as you can yourself, and then check your answers with what I do. Don't copy what I do, because I won't be next to you when you take your tests. That's substitution. Let's do the same equation using elimination. So we have line 1 is 2x plus y equals 2. L2, x minus y equals 7. Let's say one of these two equations were ready. Let's say the second one was x equals y plus 7 already. What if this one was already like this? This is telling us, let's use substitution. It already did the first step for us. So now let's plug this into there. So if it's already solved for a variable, go from there. Ah, would that work in elimination? No. That would work for, that's substitution, isn't it? Elimination, we have to be in this form. Because you have to be able to add the two lines together. So if it's like this, rewrite them. 2x plus y equals 2. Line 2 is x minus y equals 7. Because elimination, we have to be in this form. When we add the two lines together, then we have to eliminate a variable. This works great for substitution. If it was given to you like we had earlier, then use the substitution method. All right, so we're going to get rid of the y's. If we add these two lines, we get 3x. The y's already cancel. This is equal to 9. Divided by 3. X equals 3. That's my first answer. Since we have x equals 3, we can choose either of the two original equations. Which one do you want to solve for? Line 1 or line 2? Okay, let's use line 1. X equals y plus 7. We know that x equals 3. Subtract 7 from both sides. So y is equal to negative 4. So our solution is 3, -4. What do you think? Pretty easy so far? All right, let's do example 4. Let's use the elimination method for this one. Line 1 is 4x plus 3y equals 11. Line 2 is -5x plus 2y equals 15. We're using elimination. So go ahead, work it out. All right, for elimination, we have to pick a variable to get rid of. Which letter you want to get rid of? Okay, we'll use y. But remember, what do you have to have in order for elimination? You have to have the same number, but different signs, right? This already is a different sign, so that's half it done. This is both positive and they're both different, so we have a lot more work there. But I would have chosen X because the half it's already done. Okay, so but we'll use line X for you guys. So what do we have to multiply to one or both equations so we have the same number but different signs? We have to have the coefficient of y to be the same number but different signs. Yes. So the top one will multiply by -2, and the bottom one will multiply by 3. Because that's the only way 3 and 2 will become equal. So line 1 is now -8x -6y equals -22. Line 2 is -15x plus 6y equals 45. If I distribute that 3 to all these, and this is not up there. Now I can add them together. The 6's cancel. -15 minus 8 is -23x. 45 minus 22 is 23. What do I do next? How? Again, when will you learn? Never divide by a negative number. It may work a couple times, but more errors occur when students try to divide by negative numbers. Too many signs, too many horizontal lines everywhere. I've been trying to tell you guys from day one, do it in steps. First step, change the signs. Then divide by 23. X equals -1. Most errors occur because of negative signs. A lot of them happen because people try to divide by negatives and they just forget about them. They get lost in. Think about it. You have a dividing line. You have the equal signs. You have another dividing line. You have too many horizontal lines everywhere. You'll get it mixed up. I'm trying to help you guys so you can do what you want, but for the 12th millionth time, do never divide by negative numbers. So what do we do with this -1?
plug it into an equation.
Plug it into either of the original equations. Line 1 or line 2, which one are you gonna plug it into? All right, we'll choose line 1. So that's 4x plus 3y equals 11. So anywhere I see an x, I put a -1. And solve for y. So it's -4 plus 3y equals 11. Add 4 to both sides. And divide by 3. Yes, I know what I'm doing. Some of y'all know how to look up and copy. Don't do that. Try to do it yourself, then just check your answer. That's my solution. Now let's look at some other possibilities that can occur. So far, each one of these have only had one solution. Let's see what happens with these equations. A, line 1 is x minus 3y equals 1. Line 2 is -2x plus 6y equals 5. Do you want to use the elimination or substitution method here? It doesn't matter to me. They both ways work. Any substitution? All right. Okay. Side note, I would have used elimination because if you look at it, the coefficient of that one's 1, this one's 2. So what do you have to do to get this one to be the same? Multiply by 2. But that's okay. That's both ways will work. So whatever easiest for you. So which line do you want to use and which variable you want to choose for? Line 1 for what letter? So we use line 1. We have x minus 3y equals 1. We're solving for x, so we move the 3y over. But no, again, it's whatever you're comfortable with. You saw it, it's a substitution or substitution jumped out at you. If that's more comfortable for you, great. And always go with what's your strong points. Now what do we do with this? Yep. Go to line 2, -2x plus 6y equals 5. Anywhere we see an x, we put a 3y plus 1. It's not much more difficult, I'd say. Now what? And then so -6 and 6 cancel. Ruh-roh. Is -2 equal to 5? So what does that mean? If you ever get to a point when this happens, everything just cancels out and it doesn't equal, what do you think it means?
Or over the same line or parallel.
If it was the same line, wouldn't they be equal? Since they're not equal, they're parallel lines. They're inconsistent and independent. They have no solutions and nothing can make them the same. These are parallel lines. So what does that mean about solutions? Since they're parallel, they have no intercepting points. They have no solutions. So whenever this happens, when you go through a step, all the letters are gone and you just have two numbers. If they're not equal, then they're parallel. If they are equal, then what? Then they're same lines, which is what the next one's going to show us. Okay. If the variables disappear and the remaining numbers are not equal, then the lines are parallel. See, this is how you take notes. You should have written this. Instead of writing these numbers up, this is noteworthy right here. This is the notes you should have had on your sheet before I did this. That's how you take notes in college. What's the takeaway? What's the important part about this example? Well, all the letters are gone, numbers don't equal, then they're parallel. That's what you should have put down before I did that. And B, we have line 1 is 2x plus 3y equals 6. Line 2 is 4x plus 6y equals 12. Which method do you want to use here? Okay, we'll use elimination. So for elimination, what do we have to have?
Same coefficient. No, same coefficient, but different sign.
What's that what you say? Yeah. Yes, you have to have the same coefficient, but same but opposite. Yes, same number, different signs. So which line do you want to change? Line 1 or line 2? And how? Line 1, what do you do to it? Very good. Let's say get rid of the x's. So I multiply by -2 because I can get a -4 in the first one. So this becomes -4x, -6y, -12 over 4x plus 6y equals 12. I add the two lines together, what happens? Does 0 equal 0? Yes. So what does that tell us? Same line. Infinite solutions. So they're consistent and dependent. Let's see, this is elimination. What would it look like if we did substitution? If we did substitution, what would it look like? So which line, which variable do you choose and solve for? So since we're on a roll, let's use 1 and we're going to solve for x. So we've always been doing. So we have 2x plus 3y equals 6. Solve for x. Move the 3y over first. And divide by 2. So X is equal to 2 or negative 3 over 2y plus 6 over 2 is 3. That's the first one. So now I plug that into my second equation. So anywhere I see an X, I put this whole equation in. So it's 4 times negative 3 over 2y plus 3 plus 6y equals 12. Go ahead and work that out. Well, I switch everything over to the next side. Distribute the 4, so we have 4 times negative 3 over 2y plus 4 times 3 plus 6y equals 12. 2 and the 4 cancel. So we have 2 times negative 3 is negative 6y. 4 times 3 is 12. Combine like terms. So in substitution, whenever all the variables are gone and two numbers equal each other, then it's the same line and infinite solutions. So if the variables disappear and the remaining numbers are equal, then they are the same line and have infinite solutions. Let's look at word problems now. In your sheet, in your packet, we're going to look at these two, maybe three problems. What did I give you guys? In your packets, I gave you this. Snack mixture. At Max's Munchies, caramel corn worth $2.50 per pound is mixed with honey roasted mixed nuts at worth $7.50 a pound. In order to get 20 pounds of a mixture worth $4.50 a pound, how much of each should be made? Or should be mixed? How do we start this? We start off by putting down what we're looking at. Well, what do we have? What are the titles of these columns? This is the item. So what are the items? We have caramel corn. That's that one. And then we have mixed nuts. And this is what the mixture is going to be. How much of each should we mix together? So what do we know about each of these? How much do they cost? What's the price? What's the price per pound of caramel corn? 250. And what's the price per pound of the mixed nuts? $7.50. And we want the mixture to cost how much? I have to be here Monday anyway, so if we don't finish today, we'll come back Monday. So again, the faster you respond, the faster we can go. Now, what do we need to know here? We have the price. What do we need to know next? We have the price per pound.
Wait.
Yeah, well, the number of pounds. How much of each should I use? Do we know how much caramel corn we need? No, so we call that X. Do we know how much pounds of mixed nuts we need? No, we'll call that Y because we have two different variables because we have two different items. How much should the mixture weigh? 20. Now here's the value of that mixture. So here we have caramel corn, which is 250 per pound. So it's 2.5x. If we take that, and the next one is 7.5y, this, how much is the mixture? We have 20 times 4.5, which is how much? Since there's a 0 after the 20, we move the decimal over. So it's the same as 2 times 45. What is 2 times 45? 90. So our equation says this. If we take the caramel corn, add it to the mixed nuts, we should equal the amount of mixture. So do we have, remember, we're doing system equations. Do we have two systems here? Well, look at the number of pounds. If the number of pounds of corn plus the number of pounds of nuts, shouldn't that equal 20? Yes, we do have. Again, I asked you once before, never respond to my questions before you think about it. I barely even finished the question. Somebody going, no. How? Do not answer until you look at everything. So what are my two equations? And then 2.5x plus 7.5y equals 90. Now, to begin with, we don't like dealing with, at least I don't like dealing with decimals. How do we get rid of the decimals in the second equation? How do you get rid of that one decimal place?
By everything we do.
By 2?
So it becomes 5 and 15.
By 10. That moves the decimal over. So we have x plus y equals 20, 25x plus 75y equals 900. Let's see what's next going to be. All right, so which method do you want to use to get rid of these? Hmm? Okay. Okay, you're going the longer way, that's okay. Which show substitute, you have to find what equation, what variable. So we're doing line 1 for what? For y. So we're taking line 1, we have x plus y equals 20. So y is equal to negative x plus 20. What do we do with this equation? Right, now we have to use line 2, which is 25x plus 75y equals 900. Anywhere we see a y, we plug in that equation. So it's negative x plus 20 equals 900. So we have positive 75 times negative x, so it's negative 75x. Positive times positive is positive. 75 times 20. 75 times 2 is 150 with a 0 behind it. Now what? Combine like terms. 25 minus 75 is positive or negative? 75 minus 25 is? Get x by itself, we have to get rid of what? Let's subtract 1,500 from both sides. So we have negative 50x. And it should be negative. 15 minus 9 is 6. Change the signs. Divide by 50. So x is equal to, one of the zeros cancel. 50 goes into 6, 55 goes into 6 once, with 1 left over. 5 goes into 10 twice. So x is equal to 12. Now we combine these two equations here. Y is equal to negative x plus 20. We know that x is equal to 12. So negative 12 plus 20 is 8. So to answer the question, it was asking, how much of each snack do we need?
12 pounds of caramel corn.
12 pounds of caramel corn and 8 pounds of mixed nuts. Those are your answers. Whenever you deal with word problems, your answers are in words, not just numbers. On your page. Look at this one. Now this is a motion problem. What does that mean? Whenever you deal with motion problem, what formula do you have to use? Which is? Right. Distance equals rate times time. How far rate? How fast do you go for how long? That is how fast you go, how far you go. All right, what this one says, An airplane flies 3,000-mile distance from Los Angeles, California, to New York with a tailwind. What's a tailwind? A tailwind. The Japanese, before World War II, discovered that because of the Earth's rotation, at higher altitudes, the wind goes from west to east. It's called a jet stream. It goes a couple hundred miles an hour. And so that's why what they did is they launched balloons, and these balloons would go over the Pacific Ocean and they would drop bombs on the west coast of the United States. And yes, it did attack and a lot of people died, but it was covered up. But that's what Japan. That's so now because of that, anywhere between there, also when we have what's called tailwinds, tailwinds are winds that blow from behind the airplane. That goes with the airplane. If it's blowing the other way, if it's going towards the airplane, it's called a headwind. So in other words, the tailwind pushes the airplane forward. That's how come airplanes going west to east fly at high altitudes because they use less gas and get there faster. It's usually an hour faster going one way than the other way. So that's what a tailwind is. A tailwind is wind that's pushing the airplane faster. So we know it's going from Los Angeles to New York in 5 hours, but from the return trip from New York to Los Angeles takes you 6 hours because now you have a headwind. Find the speed of the airplane in still air and then the speed of the wind. How do we do this? So this is with wind and against the wind. And up here, we have distance equals rate times time. So what's the distance? This is going from west to east. This is going from east to west. 3,000 miles. How about the other way? Yeah, it doesn't change any. So the rate, how would you figure out the rate? The rate, it didn't tell us much about it, but we do know since it's with the wind, it's the speed of the plane plus the speed of the wind. Because we have to solve for both of those later on. What's the other one going to be? Against, we're going from east to west. That's the speed of the plane minus the speed of the wind because it's going the other direction. How about time? Going from west to east, how long did it take us? And east to west, 6 hours. So the formula would be 5 times P plus W, 6 times P minus W. So do we have our two equations? Yeah. The first one is 3,000 miles from west to east equals 5P plus W. And the other one is the other direction, 3,000 miles, 6P minus W. So far, so good. I'm setting up with respect to this formula here. Here's if you can simplify the equation before you do anything, always simplify. In other words, here, what do they both have in common? They both have a 5 in common. So I can divide this first equation by 5, both of these by 5. What's 30 divided by 5 is? So it's 600. And the 5's cancel, so we get P plus W. And the second equation, if it divide everybody by 6, I get 500 equals P minus W. So what method would be easiest to use here? This is equation 1, this is equation 2. Yeah, because we have W. If we add these two lines together, what happens? The W's cancel. So we know the speed of P is what? What's half of 1100?
5,500. No.
I know what you wanted to say.
550.
550. Yeah, you put a little bit too many zeros in there. So the speed of the airplane is 550 miles per hour. How do we find the speed of the wind?
We use that formula. Wait.
Yeah, we use either one of these two equations. Let's use the first one. 660 equals P plus W. P is 550. Subtract 550 from both. So we're left with the speed of the wind is 50 miles an hour. So the speed of the airplane in still air is 550 miles an hour, and the speed of the wind is 50 miles an hour. Okay, the last one is pretty much set up for you. Supply and demand. Suppose the price and the supply of the star station satellite radios are related to the equation y equals 90 plus 30x, where y is the price in dollars at which the seller is willing to supply X thousand units. Suppose too that the price for the demand of the same model of satellites are y equals 200 minus 25x, where y is the price at which the consumer is willing to buy. So this is what the store is buying them at. This is what they're selling them at. You see the markup? The equilibrium point, the point in which the supply and demand So if we looked at this thing, we have 50, 100, 150, 200, 250. And this one's going to be at 2, 3, 4. So this one starts at 200. The slope is negative 25 over 1. So down 25 over 1. So that slope is like this. This one is 90 plus 30 over 1. If this was inaccurate, this would be the point of equilibrium. My graph is horrible. That's why I don't have the graphs, which is why we use the calculations, the numbers. So we have y equals 90 plus 30x, y equals 200 minus 25x. Even though we said that there is substitution elimination, is there a third method we can use to solve these? Not yet. Since they're both equal to y, the y's are the same values. Wouldn't y, let's call this one y1 line, wouldn't y1 equal y2 if they're the same letter y's? So we can do that. We can set them, solve for y, and set the equations equal to each other. So we have to get all the x's to one side, non-x's to the other. So since 30x is bigger than negative 25, we move all the x's to the left side. $90 plus 55x. Subtract 90. So we have 55x equals 110. Divide by 55. So x is equal to what? 110 divided by 55 is 2. So that's how many thousands of units we need. Because the x's are thousands of units. So this is thousands of units needed. What's the y value? We can use either one of these two. It doesn't matter which one. Let's use y1. 90 plus 30x. X is 2. So 90 plus 60 equals 150 dollars. So the point of intersection is 150. So 2,000 units at a price of 150. That's the point of equilibrium. So far, so good? That's systems of equations using just algebra. Now we're going to use something called Cramer's rule. Stop this one, and then we'll start Cramer's rule.